Um, we are going to be using the alkynes worksheet that's under the recitation files. If you guys want to pull that up, I need to get it up on my screen. Okay, so let's start with some of these reactions where we're making alkynes. They're pretty straightforward. If you add in a small base, it's going to selectively deprotonate your more substituted center. Giving you your triple bond at that position versus a large base, which would selectively deprotonate your less substituted center. Alternatively, if you have two secondary centers, it's just going to do both of them. You're going to end up with a mixture of products. So, for instance, let's see. For this here, both of your adjacent centers are secondary. So for something like this, you're just going to end up with two different products. Like so. If your double bond is, or sorry, if your BRs are splitting, so if you have this pattern here, because you have such a nice induction, this is always going to lead to a product where your triple bond is going to form in between the two of them. Okay, so let's take a look at that worksheet on alkynes under the Files tab. We're going to skip the two nomenclature questions. Let's just start on these reactions. So do the first three reactions that deal with forming alkynes. I'll give you guys about maybe 3 or 4 minutes to kind of try to work through them, and then we will go through them together. So I'm going to get them written up on this screen here while you guys are starting to work on them. I don't know why I have these labeled as two steps. One of them should just be, this is just the solvent, the ammonia at the bottom here. So I'll rewrite this a little cleaner. All right, so let's get started on some of these reactions here. We've got a secondary center on both sides of this, which means it's not particularly selective. It's going to end up either forming a triple bond on one or the other. So it's going to give us two different products to this reaction. We can either get, let's see, 1, 2, 3, this triple bond, or our symmetrical one here. At our next one, we have a quaternary center, which means there's no H's to pull off to do an elimination versus a secondary center. So this could be selective for that secondary center, because you'd be making like 6 bonds to carbon if you try to do it on the other side. So this should end up giving us a triple bond that looks something like this here. Same thing on the next one. When you have these that are 1 carbon away from each other, they almost always form that triple bond in the middle. We'll talk about some examples where they don't next section or next unit after this first exam, but for right now, you should pretty much know that that's where your triple bond is going to form. So taking a look at this, going to form our triple bond in between these. Any questions up to this point? Okay, so let's do some reductions. We have 3 different flavors of reduction we can do, starting from a triple bond. If I take H2, this is going to just reduce down to single bonds. If I use a poison catalyst, like Linlars, so platinum was our catalyst on top, Linlars is going to be our second option. Nope, wrong thing. This is going to let us form a cis alkene. So if we think H2 typically adds syn across these bonds, we add in this poison catalyst. It's going to stop us after our first reduction, and we're just going to end up with this cis alkene here. Using somewhat of a different reaction, we're going to throw in sodium 0, which is a radical initiator, so Na and ammonia. This is going to let us get to our other option, which would be a trans double bond. So I'm going to give you guys, I don't know, about another 4 minutes, let's say 5 minutes to go through the next, basically the bottom half of the left column here. Try to do these 6 problems, figure out what their answers are, and then we will talk through them together. All right, so hopefully these ones are pretty straightforward. We're just reducing down to single bonds for these first two. Our next one, H2 and Lin-Lars. H2 adds syn, so we're going to end up with cis products. So Lin-Lars is going to stop it halfway through. So we need to make cis double bonds for these. And then finally, our sodium and ammonia is going to make trans bonds. Which should look something like this here. Any questions on these reductions? Okay, so some single brominations. Like we're doing with our alkene, we add an HBr. We'll brominate in our more substituted position. Doing it to an alkyne. For one equivalent, you can form an alkene with a bromine on it, and then if you're doing this in excess, you'd be able to dibrominate. So going to the right side, do these next two problems. Do them for both one equivalent and excess. So I'll draw what I mean on the iPad, just like another arrow like we did over here. And then we'll walk through these. I'll give you guys about maybe 2 minutes to do these. All right, so doing a single bromination. Did I mute myself? Nope. Okay, so doing a single bromination. Adding Br to our more substitute position. Adding an excess Br is just going to duplicate this. Allowing us to dibrominate. Same thing in this bottom one. First step of the bromination. Is going to give us Br here. Second step is going to add a second one. Giving us our final product. Any questions on this reaction? Let's do the dibrominations first. I think it's a little more straight, kind of the next linear step. So Taking the same concept, Br2 with an alkene. Gets us to anti-addition of bromines with an alkyne. We're also going to get anti-addition in our next step here when we're adding in a second equivalent of Br2. This is when we're going to lose our stereochemistry because we're going to tetrabrominate. We're going to have two bromines in the same center, which means it's no longer chiral. To give us this product. So, same concepts as before. We are just doing more brominations. So we're going to do the last four on the left column first, and then we'll go back up and do these hydration reactions. So I'll give you guys another 2 to 3 minutes to do the last four ones, and then we'll talk through them together. I'm going to write them out a little differently to kind of simplify it. Same thing as I did in the other ones. All right, so our first bromination is going to add them anti to each other. In our second bromination, they're just going to be completely tetrabrominated, so it's not going to matter. Same thing down at the bottom. Anti in our first step, completely brominated in our second. Like so. Oh, on the sheet it has CCl4 on the bottom. Just chloroform. It's a solvent. You don't really need to put it in there. We're not going to talk much about solvents this term because we're doing summer semester. We have so much less time. So you can ignore the solvents for this one. All right, so H2SO4 and water with an alkene. It's just acid and water. Gets us to this OH here. We do it with a triple bond. Similar concept. Tends to need this mercury sulfate to kind of move it along. Initially, we'll get the same thing here. This is going to go through a tautomerization. We're going to pick up, I'm going to draw it on one step. We're in acid. Pick up a proton here. This will grab one. Shift our double bond down. And this will turn this from what's called an enol into something you guys are more familiar with, which is a ketone. Similarly, BH3THF, or just BH3, I think I wrote down for this one, NaOH. Again, THF is another solvent. Not really that important. Adds anti-Markovnikov for a triple bond, same reagents. Would get us to this temporary enol here, an OH minus. Pick up this H. Formaldehyde. It's going to grab the other H. And we're going to shift this into an aldehyde. So for these terminal alkynes here, our acid and water ends up making ketones, and then our BH3, sodium hydroxide, and hydrogen peroxide are going to end up making aldehydes. So the middle four problems on the worksheet's first page, I guess it's 3, 4, 5, 6. Go through those over the next, I don't know, let's say 2 or 3 minutes, and then we will talk through them together, and then do a couple ones on the back page for taker quiz. All right, so just looking at our triple bond here, we got a primary and a secondary one. We're in acid, water, and mercury sulfate. We're going to end up forming a carbonyl on our secondary position, or a ketone. So we can just go ahead and draw that. Simplify this out. Same thing with this second one. Going to form more ketone in a more substituted position. Being in peroxide, for these second tier reactions, we're going to be forming in our less substituted position. So these are going to lead to the opposite products. Or we're making aldehydes. I'm going to skip over the ozonolysis. We can come back to those if we have time. Oh, cat's coughing up a hairball. Oh, it's okay, buddy. For these alkylation reactions, you can either do a single or a double one. I'm going to do one of these as an example. So if I throw in NaNH3, NH2, and we did a lot of this in class today. Can pull off a proton. Which can then attack. It's going to elongate our chain by, in this case, 3 carbons, 1, 2, 3 here. And then similarly, we could do this in a double fashion. Like so. So the left half of our molecule coming from this bromo alkane, and then the iodo providing the second half here. We're running a little short on time because of our quiz, so let's do the 2 problems on the right side that are remaining with the aromatic and regular rings. I'll give you guys about 2 minutes to go through those. We'll go through them together, and then we'll take our quiz for the day. All right, so these seem large and intimidating, but really there's not that much going on with them. We're just adding these groups to the end of our alkenes. So in the first two steps, we're going to add, basically replace our BR with an alkene here. So we'd end up with this aromatic ring attached to our triple bond. And then that'll do an attack on the other side. Giving us this product. Same thing over here. We can start by drawing our first ring, just removing that BR, replacing it with our alkyne. The alkyne would do an attack on our other one, so that BR is going to get replaced. We need one carbon, followed by our 5-membered ring, and then that methyl group coming off of it. Are there any questions about these? Nope, doesn't matter which hydrogen you choose to deprotonate first. It's symmetrical, so you could draw this the other way. Like you could have it drawn same molecule. Just rotated it. So it doesn't matter which one you pull off first. Okay, so I'm going to stop here. We're going to do a quick quiz. I'm going to have you guys turn on your webcams and pull out a scrap piece of paper. If you want to do it on like an iPad or something, that's also fine. Let's see, I need to stop sharing this one. So it is just 4 questions. Draw out the major product for these. When you're done, you should be able to submit it through Canvas. You don't have to stay once you're done, so you can log out afterwards.